Today's agenda, as usual, we will have introduction of any newcomers. Then we will have project updates in about 5 minutes. And again, if any ad hoc topic, anyone can bring the topics, like any certificate, any specific issues to be talked, or you want to bring some works that you have done related to NebulaGraph, you want to share to the community, anything, or some interesting topics to be discussed. And there will be a sync discussion of the open floor time in the end. So today I prepared an ad hoc topic related to NebulaGraph Spark connector and NebulaGraph algorithm, working with the NebulaGraph cluster running on top of Kubernetes. So this is a hot topics discussed in the community in last couple of weeks that I consider worthy to be shared. So all the agenda and topics anyone can put in this Etherpad. It's a online pad that useful for the community collaboration. And more information, please refer to our wiki and Slack channel. You can reach out to us in either from the pad or in the Slack. And I think, let me check newcomers. Oops, maybe. Okay, I didn't share my screen. Okay, I'm sharing. Okay, there is no newcomers, unfortunately, this time. So I will go solo again. Okay. This is me, Wei, as usual. Again, I want to give a brief introduction of our way of working of the community meeting. And you can see that what will happen bi-weekly. And you can subscribe our register it on the Zoom or subscribe our Google Calendar. You will have a reminder before the meeting. And during the two meeting points, you can propose your topics, or you want to involve some part of the community in next meeting or coming meetings. You can request that from our different channels, and we will try our best to arrange. And during the meeting, we will go through the routine topics and your ad hoc topics, your proposal, your idea, your story. And afterwards, we will archive everything, including the video and the text version of the information, and you can check it in any time. So that's the way of working. And then we will start our first part, the project heartbeats of the last 2 weeks. The very first one is we have a minor release, which is the the final .2, which is the minor version. And there will be no break change, but only hot fixes. And this actually only 3 issues was fixed in this release of the core part. And the main part is a memory issue. You can refer to the contents of the release page. And this is the trigger of this release. And we also put other 2 hot fixes in this cycle. Regarding the master core, there are mainly only 3 parts merged for 2 reasons. So it's not a lot of contents, because one is the last 2 weeks are a public holiday, a long holiday in China, and most of our community members are Chinese. So there wasn't too much work in the last 2 weeks. And another reason is we are in a time that we already have a release basically release candidate of the major release that we already introduced, the v3.0, and we are in a phase that doing the stability test. So the major part was already merged. So only two new features. One is the Snowflake ID, which is the universal unique ID generation function that user was already eager to have this, and they requested in a couple of different issues. We managed to make it happen and merge in the master, and basically it will be included in the v3.0. And the UUID clause was bring back. So if you are old user in NebulaGraph, you know that in version 1 we already have a similar clause, but you have to put a seed inside, a string seed as an input argument of this function. This is because in v1 we only support the number or the int format of the vertex ID. So when your identifier of your vertex are a string, you can leverage this UUID function to make it into a number, to hash it. But when it comes to v2, we have a string format of VID supported, and we remove this function. And in this time, when we want to bring the universal unique ID function, generation function, we reuse this keyword. So you can refer to more information from the pull request, and there will be documentation in coming weeks. Another major function is we now support a single server or the standalone. So what's the difference between this single server and you deploy 3 different services in single server? So the difference is now there will be only one service, and especially for the GraphD function and the StorageD function, they will be in one thread process, sorry, and there will be no RPC call between the GraphD and the StorageD, so it will cost less, so performance will be much better in the single server or standalone scenario. So as I recall, the meta, the cost to metad is still RPC, but you know, it's not a major part of the performance. So have fun with that. You can check out the pull request, and there will be documentations on how you can configure it, and you will have only single service to leverage your single server mode. The next one is a bug fix that, and there will be corresponding PRs on the BR side. So so it's observed that if your cluster is upgraded from v2 to v3, and your BR will have some issues, and it's fixed. So on the other side, on the Kubernetes operators, welcome, Hera. Hi, Hera, welcome. So you are the very first member joining our meeting, and I will continue on this topic, and between before next topic, I will invite you to give a brief introduction. Okay.
Do you mean me? Okay.
Yeah.
Okay.
Okay. Thank you. So I will continue the Kubernetes operator part. We have a new PR merge, and it's related to the POD spread constraints. So that's related to the spread policy. So you can refer more information from the PR that this configuration flag was introduced. So, and by default is, I don't remember the default value, but if I recall it correctly, is that if your spread situation is not satisfied, it will do nothing. It will not create new resources, as I recall. You can, if you have net questions, you can discuss with us. So this is a new function on the Kubernetes operator of the NebulaGraph. Another thing is that we have created a new project with a Kanban board in GitHub regarding the next release cycle, which will be approximately 3 months later, 3.1. So you can check out this projects, and there will be you will see the major works tasks that is ongoing or done from that view. Another thing is NebulaAgent, as we introduced in 3.0 preview, it's a new process introduced mainly for now. It's mainly helpful on the backup and restore. So maybe in future there will be more functions included. So the very first release was just done yesterday. So check out this tag page. So basically that's the main part of the project Heartbase. So before we move to next, we will welcome our new member of the community meeting, Hera. So Hera, can you introduce yourself? Maybe turn on your camera if it's comfortable to you. It's not necessary.
Wait, then.
Up to you. It's up to you.
Okay, then I will not today. Not looking so good. So I'm Hera and one of the NebulaGraph community member, and just want to know what's going on for the product and the community. So can continue, please.
Okay, thank you. So Hera is one of our my mates, my work colleague in the community operation teams. So she's a very kind-hearted and very funny, great girl. Feel free to reach her for the questions in the future. Thank you, Hera. So we will continue.
Yeah.
Yeah, the next part is the ad hoc topic that I prepared. It's regarding how we can run Nebula-Algorithm on top of NebulaGraph deployed on Kubernetes. So why this is worthy to talk about, you will know it later. So I will start with a couple of different perspectives, which is I consider most of them are the prerequisite background information for this topic. So first, I will give a brief introduction of the architecture of NebulaGraph. It's crucial to this topic. So this is the page of the documentation on the architecture overview. We all know that there are 3 services for NebulaGraph, and they are the GraphD, which is the graph service or graph daemon, the MetaD, which is the meta service, and the StorageD. So GraphD is actually in charge of the graph query handling. That is when you are doing the NGQL query, the match query, and your session, your client will be talking directly to the GraphD. Welcome, Jamie. And I will invite you to give a brief self-introduction later when I finish this part. Okay. Maybe your audio device is with some issues. Maybe you're talking. I see you are not muted, but there is no wave of your voice. So I think you already hear me. So I will continue, and after I finish this topic, I will cue you. Okay. So I think it's okay. Okay. So anytime you are making, for example, from your Nebula console or other clients, you are making queries or write data into NebulaGraph, you actually are talking to the GraphD directly and only talking to GraphD directly. And like, for example, you are making a login session, the metadata will be involved because all the metadata or the authentication data and the cluster distribution data are, the metadata of the graph. So they are all persistent handled by the metad service. And for your user and password information. But when you are logging with the GraphD session, that you are not directly talking to the meta service, and instead GraphD will be a proxy to help you to check with the metad service. So, and when you are actually querying the graph data, the GraphD will talk directly to the storage daemon or storage service. So all the query are only directly through the GraphD services to the end user or the client users. So that is the basic information regarding the service. But there are certain cases that the end user can somehow leverage the clients to directly talk to meta service and the storage service, but that's not the most general use cases that I will review later on that cases. So, and this is the basic information regarding architecture part. And then I will not go through all details, but only the related ones on this topic. So the next one is how Nebula service are landed in a Kubernetes environment. So I will demo you from this. So this is a Kubernetes environment that I deployed. And this is the service view. So we can see the pod view. Let me see. Oops. Sorry. So this is the pod view. You can see that there will be storage D instances, the meta D instances, and graph D instances, and they are all the the pod of the Kubernetes services resources, and underlying they are just containers, right? But how can we talk to them? So this is related to services. So when it comes to services, we notice that for both GraphD, metad and storage, they are services, but only the GraphD is actually service with the cluster IP. And for metad and storage, they are headless. That is without any cluster IP. And that is by default when we spawn a Nebula Graph cluster through the Nebula operator, there will be, it's not possible to access the Nebula Graph cluster directly to the GraphD and to the metad and storage D. And that's by design for a reason that I explained in last part that for normal use cases, we only talk to the GraphD, right? But so that is the main information that I want to review in this part. Let's back to the main page. So I will explain. You already know that it's by design, and that break has and that's for good reason, because we normally use queries to talk with the cluster. But I will review more information on the later part on the Nebula-Algorithm, which obviously require more than that. And that's why we need to talk about this topic. Then we will go to a next part, the service discovery in Nebula Graph. And that's a major part, help us to understand why we should or should not do this during this scenario. So how Nebula Graph services discover each other. So the thing is, all the service states are actually maintained by the meta service, and the service information is also meta for the Nebula Graph cluster. So and literally they should be put here, right? But how are they found or discover each other? So the thing is, when we boot up a cluster of Nebula Graph, we should first boot the metadata service always, because that's the the meta of the graph, right? And then a but if you have more than one metadata service, they should be aware of each other. And how could they know each other? And that's of the first part of this discovery. So we should configure them in each of the metad instances. So that is, you should configure your metad configurations and let it know all the other metad addresses. So it will check through that IP and POD to communicate each other. So metad service is ready. Then we will start the storage D. Storage D need to know where the metadata, where the meta service is. So they need to know this information through the storage D's configuration. So storage D will know all the metad instances, and it will communicate with them. And also, the metad will in this communication from storage D to the metad, the metad will know the storage D's address. So that's a service discovery typically, right? But how metad will know exactly the storage D's IP and POD? It comes to the configuration again, and the information info flow will go from the storage D configuration. So storage D will have a configuration of itself on which IP it will be listening and which port it will be listening. And then this information will be passed to metad. And how graph D will discover the storage D. The graph D, then after the storage D will be up, the graph D will also be up finally. And the flow will be, the graph D will config to the metad service, so it will know where the metad is, but there will be no storage D configuration to the graph D. Graph D will get the storage D information from the meta. We already know what meta is measuring, doing, right? So the main information here is that normally the client side or the consumer of the storage D will not know the storage address or IP directly. Instead, it will get information from the metad. And our takeaway is where the metad, how will metad know this storage D's addresses? It will come from the storage D configuration, and storage D will let the metad know this information. So that is the key point of this part of how this service was discovered in NebulaGraph. So the next part is Nebula-Algorithm. So Nebula-Algorithm, we already know that it's an application to enable Nebula graph to have the graph algorithm on top of the graph data in NebulaGraph. So you can check more on the related, either on related GitHub repo or from documentation here. But I will not go into details, but I will give you some brief introduction of the configuration of the algorithm. So Nebula-Algorithm is underlying a Spark application. So you have to run Nebula-Algorithm on a Spark cluster or Spark runtime. So each time you want to trigger algorithm computing, you will let the algorithm program to talk to the NebulaGraph cluster and to know which algorithm you want to run. So how we should let algorithm to know that is configuration, of course. So here, I will show you the pod. In my environment, I set up a pod that's running a Spark inside, and then we'll go inside this. So I will show you the configuration example of the Nebula algorithm, and that's related to our survey, to our problem. So by default, so we will start the configuration part. So this field is, the Spark related configuration, we will give this Spark app a name. So in this example of a configuration, it's the LPA algorithm. So we'll give a name, and I'm not going to dive into all the configs, but only related. So on data part, it's related to how this algorithm application will get info, read info from the source, and sync will write info to another target. So the source here is Nebula, and there are other options of CSV and JSON, of course. So Nebula refers to the Nebula-Algorithm will talk to the Nebula cluster, and the sync will sync to a file. Also, you can choose to sync to the Nebula cluster, but in this case, I just sync the computed information in a file. And this is the Nebula part. If you choose the source as Nebula, you will configure the related read inside the Nebula configuration. But the main part here is related to the addresses. You will know that the only information you talk regarding the connectivity of the NebulaGraph cluster is the meta address. We already know that with the meta address, you will know all the other service addresses. So that's reasonable, right? And here you will notice that we put a domain name with the port, and the domain name is so long and a little bit weird, but I will show you why. We can see this is a console connected to this Nebula cluster. So when you see show host meta, you will know that by default, a cluster spawned by the Nebula operator, the address configured by the Nebula operator will be something like this. And that's why we put it in a configuration like this. And this is a space, and this is the label, which is a tag of the graph we want to compute. And this is the edge, the properties of the edge, which is start here. So this is the main information that I want to review for why, for how we want to run Nebula algorithm on Kubernetes. So with all this information combined, I think you already know the key points of how we want to do this. And actually, so the main takeaway is you need to specify the meta address in the application, and by specifying that, the underlying requirements is your Spark will need to have the ability to talk to the metad address, which is I showed you, which is a headless service. And then actually your Nebula algorithm or your Spark environment will need to talk to the storage service as well. You can see from here that the storage addresses configured in your storage service and then discovered by Meta. The information can be queried by host storage, and they are also headless services. And as I already shared in the first part, that second part, all the headless service cannot be accessed outside of the Kubernetes cluster. So you have to put your Spark inside. Either you put your Spark inside your Nebula cluster, or you make some hacks needed in operations configuration with leveraging the Kubernetes ingress. But in this case, in a simple case, I will show you that I'll put the Spark in the same cluster. So details on how to I already put on this repository. Also, this is a repository help user to play with the Nebula operator in the kind. So kind refers to Kubernetes in Docker. So it's a very small footprint on your single server or even desktop. Play with the Kubernetes, and I put everything ready to use. On this environment, you can in one liner you will have a Kubernetes in Docker and a Nebula cluster inside that, and there will be a chapter called "What's Next." I will click this, and you will see what's next here in this README of this repo, you will see the steps on how you want to run a Nebula algorithm. And actually the key point I already shared with you, that you will have to run your Spark with the same network of the Nebula cluster, and you want to configure the corresponding addresses in the headless services. And that's after you follow this step-by-step tutorial, you will have everything ready to use. So okay, and this is the main part of this topic, I think. So I put the major steps here. So this line is referring to you spawn the cluster, and that's one is you want to create your Spark pod with this line, and then you will have this line to access the Spark console, and then you will continue to configure the algorithm configuration and then run the algorithm application. So I think that's all part of this. Okay, one thing to mention is that when I was preparing for this, I found a bug in the algorithm and the Nebula Java clients. I make a PR that was merged yesterday on the master, but not yet merged in the 2.6 branch. So I make a patched package. So when you are referring to my repo, that's underlying is referring to my personal build. So maybe in next week, we will have a formal release on the Nebula Spark connector and the algorithm. So I will update accordingly. So yeah, I think that's this ad hoc topic. So Jamie, are you there? Can you?
Yes, I'm here.
Okay, so welcome, Jamie. Jamie is our NebulaGraph community manager, and maybe you can tell us more about you.
Oh, okay. I'm not quite prepared for that. So and thank you, Sue, for such an amazing community meeting. And I'd say we're going to keep doing this and providing more information about the NebulaGraph community and keep the community updated about what's going on in the community. Yeah, and hope more and more community members can join this community meeting and share their ideas about what they want. Yeah, how they want to join the community. Yeah, and I think that's all.
Yeah.
Thanks again,
Thank you, Jamie. Awesome. So then we will go to next part. Oh, final. Yeah. So we basically finished all the agenda topics, and so be subscribe our calendar or register our Zoom meetings to not missing one. And we'll next meeting will happen 2 weeks later, and reach out us from our from the Etherpad and propose your topics and put it there, or talk us from our Slack channel. And finally, before we finish it, I have 2 news to announce. The one is regarding the vSoft team, that our NebulaGraph cloud, which is the NebulaGraph as a service providing, will be open beta soon, maybe later in this week, hopefully. So stay tuned, and you can play with that managed service on a public cloud infrastructure. So it will be easier for many teams, as I believe. Another news is I will be giving a talk regarding NebulaGraph and some know-hows on the DOK, which is the Data on Kubernetes community, later in this week. So you can reach out to subscribe this live streaming on YouTube from here. And I think that's all from today. And we can call this end. So I see only Jamie joining on this meeting, so we won't have a sync discussion. So we can say goodbye and see you in next week's.
See
Bye.
you, Wei.
Bye.
Bye-bye.
Bye.